in this slide, we have y equals to ax. Now, it is important to diagonalize the matrix A into PDP minus 1 whenever we have a condition where we need to compute, for example, yn equals to a to the power of nx. Now, where we have to compute a many times, a times a times a. Now, let us see why. Let's examine the problem where we have such a system where the next value of x, or the output value, is equals to the previous value, a times the previous value. What happened is that if you observe this equation, in the first case, x1 is equals to a times x0. x2 is a times x1. However, x1 can be replaced by a x0. Therefore, now we see that x2 is actually a squared times x0. Therefore, it is obvious now that x of k is ak times x of 0. Now, a times a times a, k times is a very expensive operation when a is dense, meaning that it has values over the entries in the matrix. However, if A can be represented by a matrix D that is only a diagonal, dk, the diagonal matrix to the power of k times, is very cheap. So let's see what happens. Alright, let's assume that we can diagonalize a matrix. Means that we can convert A into the product of three matrices, PDP minus 1, and P is the set of eigenvectors. Now, when it is written in this form, it means that P has a complete set of eigenvectors. Therefore, P minus 1 exists. In this case, then A is diagonalizable. Now, so what happened in A squared? It is obvious that it's nothing but PDP minus 1 times PDP minus 1. You can change the brackets. This is the associative properties of matrix multiplications, and we can change it. Therefore, P minus 1 times P becomes identity, and therefore it reduces to this. So after a while, we observe the pattern. A3 is equals to P d cube P minus 1. Therefore, AK is equals to P dk P minus 1. Alright. Now, when we have this form, then simply to calculate x of k for very large k is a very cheap operations. We're not going to multiply a k times. Instead, what we're going to do is this. We have p multiplied by dk, and dk is very cheap because d is diagonal. Now we have p minus 1 times x0. So observe this operation. Remember that x is in the standard basis. When we multiply something by p minus 1, we are converting from the standard basis into the b basis. We are transforming in the b basis using d k times. And then finally, we are transforming back into the standard basis by pre-multiplying with p. Alright, so maybe if you observe this picture, from the standard basis to the b basis, we pre-multiply by p minus 1. To convert the b basis into the standard basis, we pre-multiply x of b by p. Okay, so that's it.